All right, double angle identities. We've talked about angle sum. Now there's a double angle identity. And they're called double angle identities because if you look in all of these, you will see that we are doubling all the angles. Pretty appropriately named. 2A, double A, twice A. Notice that you have three options for cosine. It doesn't matter which one you choose, they will all clean up to give you the same answer. So you just have to choose one of them that you like and stick with that one. Although it does help you to know all of them because there are some times where maybe the 2 cosine squared minus 1 helps you more than 1 minus 2 sine squared or something like that. So these are your identities. You need to know these, and we'll just go and do a few examples showing you how we will solve problems with these identities. First one, we're supposed to find sine of 2a. Now the identity for sine of 2a is 2 sine of a cosine a. So that's the identity. And I gave you that tangent of A is equal to 3/4. The problem here is my identity needs sine and cosine. I also gave you a quadrant that A is going to be between, and we're going to have to draw a triangle for this. So you need to remember tangent is opposite over adjacent. And if my angle is here, let's see, what quadrant is this? Between pi and 3 pi over 2. That's the third quadrant. So I am going to draw a triangle going into the third quadrant. There's the third quadrant. And remember, you start at the origin, go into the quadrant, and then back to the axis. Tangent is opposite over adjacent, so that would be 3/4. Here's our angle. But notice if I go into the third quadrant, I'm traveling left and down. So this would actually be -4 and -3. So I need to find my hypotenuse, which would be Pythagorean theorem, -3 squared plus -4 squared is equal to the hypotenuse squared, and you will get the hypotenuse to be 5. And your hypotenuse is always a positive measure. Do not call that -5. Once you draw the triangle, that's the hard part of this question. Now we need sine and cosine. Well, sine, remember sine of any angle, I should call this A, not theta. Sine of any angle is opposite over hypotenuse. So in this case, the sine of A is -3 over 5. Cosine of any angle is adjacent over hypotenuse. So my cosine of A is going to end up being -4 over 5. And then there's this 2 at the beginning that's going to come down for the ride. And I'm going to stick it over 1 just to create a fraction, just like the rest of the problem. Then when you multiply fractions, you multiply straight across. 2 times -3 is -6, times -4 is 24, 5 times 5 is 25, and that would be your answer. So you have to draw the triangle, then you use the triangle to figure out sine and cosine and tangent and whatever else is needed. Okay, let's try this one. Same type problem, except here I'm asking you for cosine and tangent of 2a. So let's go back to our identities. And cosine is the one that requires 3 different identities. I don't know why, but this one, cosine squared minus sine squared, is always the one I can remember. So for cosine, I'm going to use that identity, cosine squared a minus sine squared of a. And then tangent, let's go back, that's 2 tangent a over 1 minus tangent squared. So I'll change tangent 2a into 2 tangent a over 1 minus tangent squared of a. So I know sine a, and I've got to use that to get cosine and tangent. And we're going to do that with the triangle. So I'm going to take off this. Notice my angle is in the first quadrant. So I'll draw my first quadrant. My triangle goes into the first quadrant, then back to the x-axis. Here's my angle A, and sine is opposite over hypotenuse. And then we'll do Pythagorean theorem to get my third side. So I'll just call that x, and I know that 3 squared, 2 squared plus x squared is equal to 3 squared, and you get x to be the square root of 5. So my adjacent side ends up being square root 5. Uh, Once you get that, that's the hard part. Now we just plug in to what we know. Let's do the cosine one. Cosine of A, cosine is adjacent over hypotenuse. So cosine A, this thing right here, is going to be adjacent root 5 over hypotenuse, which is 3. And notice that is cosine squared. So it's root 5 over 3 quantity squared minus sine. You could do two different ways. The easy way is to realize that sine of A was given to you. It's 2/3. Or you could look over here and sine is opposite over hypotenuse. Either way, you will get 2/3. But remember that is sine squared. And then we clean that up. The square root of 5 squared is 5. 3 squared is 9. Minus 2 squared is 4. 3 squared is 9. 5 minus 4 is 1, and we don't change the denominator. So there's the answer for cosine of 2a. Now we need to do the same thing with tangent. Tangent of a is going to be a little bit uglier. Tangent is opposite over adjacent, so that's going to be 2 times, and then tangent of a is 2 over root 5. And then over 1 minus tangent squared. Tangent is 2 over root 5. And we will square that, and we'll clean this up. So 2 times 2 over root 5 is 4 over root 5 over 1 minus 2 squared is 4. The square root of 5 squared is 5. And at this point, I'm going to be kind of nice. I'm going to be okay if you stop right here. If you want to give me this as your answer, that's fine. However, if it's a multiple choice question, and we do have an exam coming up, so those will be multiple choice, you need to be able to clean that up. So now I'm going to simplify this a little bit. Let's see, 4 over root 5, I'm going to leave as is for now. The denominator, I'm going to get a common denominator, so 5 over 5 minus 4 over 5. And let's see, that's going to give me 4 over the square root of 5 divided by 5 minus 4 is 1 over the square root of 5. If you are dividing by a fraction, you flip and multiply. So 4 over root 5 times, that's not root 5, this should be just 5. 5 over 5 minus 4 over 5 is 1 over 5. There we go. Times 5 over 1. That gives me what? 4 times 5 is 20. Over the square root of 5 times 1 is square root of 5. And I may even go crazy and rationalize if it's multiple choice. So let's multiply by root 5 over root 5. And that's going to give me 20 times the square root of 5 over root 5 times root 5 is just 5. And then finally, 5 goes into 20 4 times, and this cleans up to simply 4 times the square root of 5. So a lot of cleaning up. That's a bunch of just arithmetic. Since this is pre-cal, I'm going to assume that at some point in your life you have already taken and passed a test on how to clean up fractions within fractions and stuff. So I'm okay with this answer right here, the one in the blue dotted box, but if it's multiple choice, I probably will clean up the options, and you need to be able to recognize the simplified version. So there's cosine and tangent of 2a, given that. I think there were just 2 more problems I wanted to do. Okay, solving equations. Going back to solving equations, which we talked about last week at some point. We're doing, let's see, the sine of 2x equals cosine x. One thing I don't like when I'm solving equations is different angles. Here I have a 2x, here I have a 1x. I really want to fix that. So what I'm going to do is I'm going to change sine of 2x using those identities, and I know that the sine of 2x, if we go back to that sheet of identities, is 2 times sine a cosine a. So I'm going to use this identity right here. And let me go back. Where was I? There we go. And I'm going to change this into 2 times sine of x cosine x equals cosine x. And now it should resemble a problem like what we solved last week. since I have two different trig functions, I'm going to start by moving this cosine x to the other side of the equation. I'm just going to take it and move it to the left side. And so that's going to give me 2 sine x cosine x. And I'm simply going to subtract the cosine x to move it over. So minus cosine x equals 0. And then I'm looking at this. I notice that there is a cosine x in common. So I'm going to factor out the cosine x. That's going to leave me with 2 sine x. I pulled out that cosine x minus, there was a cosine x here. I'm going to pull that out, leave me with just a 1 equals 0. And then we set each one of those equal to 0. Cosine x needs to equal 0, and 2 sine x minus 1 needs to equal 0. Cosine equals 0, that's on your unit circle at pi over 2 and 3 pi over 2. And notice I did tell you only to answer between 0 and 2 pi. So there's 2 answers. This one I need to isolate the sine x, so I'm going to move the 1 over, add 1 to both sides, and then I'll divide by 2. Sine x equals 1/2. And if sine x is equal to 1/2, again, I'm thinking unit circle. That one's a little bit trickier. Sine is equal to 1/2 right here at pi over 6, and right here at 5 pi over 6. So the answers are pi over 6 and 5 pi over 6. Because right there, my coordinates are root 3 over 2, 1/2, and negative root 3 over 2, 1/2. And remember, sine is the y coordinate. So there we go. Solving the equation, first thing I did is I wanted to get the same angle. I wanted it all to be something of 1x. I didn't like having a 2x and a 1x. And then I factored. Good, good. All right, one last problem. Another solving for x over an interval. Cosine 2x minus sine x equals 0. Again, I have the same problem. I have two different angles. I have a 2x and a 1x. I would rather have all of the same angle. So I'm going to change cosine into something else. So I'm going to go back and look at my identities for cosine of 2 times an angle, and we actually have 3 of them. I have cosine squared minus sine squared, 2 cosine squared minus 1, 1 minus 2 sine squared. Okay, so when I choose the angle, if you remember the equation, the only other trig function in the equation was a sine. So I'm actually going to choose 1 minus 2 sine squared theta. And again, I'm choosing that one because I like that it would give me only sines, and sine is what the equation originally had. So let me go over and look back at that equation. I'm going to paste those identities here. And what I was talking about just a second ago, I want to substitute one of these 3 in for cosine of 2x. And I have 3 options. I'm going to choose the one that only has a sine in it because that's what the other trig function is. So I'm taking out cosine of 2x. That's going to be 1 minus 2 sine squared x minus sine x equals 0. Then we need to finish solving that equation. Okay, so I'm going to have to solve this. One thing that scares me about this problem is that I see a sine squared and a sine to the first. So I'm thinking I'm going to have to factor this. I don't like having a negative squared function. So what I have right now is 1 minus 2 sine squared x minus sine x equals 0. What I'm going to do, since I don't like having a negative squared term, I'm going to move every single thing over. I'm going to subtract 1 from both sides. I'm going to add 2 sine squared x to both sides. And then I'm going to add this sine x. Hi, Delaney. You're in the middle of my recording. Isn't that exciting?
Yes.
Okay.
Hi, guys.
Okay, so I moved everything over, and the reason I moved everything over is because now, let's see, everything canceled on the left side. 1 minus 1, negative 2 plus 2, negative 1 plus 1 is 0, equals, and I'm going to reorder this because I like to have my squared term first. So I have sine squared x plus sine x minus 1, and this is the problem where we do that cute little substitution where I'm going to let a equal sine of x. And the reason I do that is if I do that substitution, this equation turns into 0 equals 2, instead of sine squared, it's a squared. Instead of sine x, it's a minus 1. And we get to factor this like we were in Algebra 1 way back in the day. I know I need a 2a and an a. Only 1 times 1 is 1. I know my 1 times tables, let's see, minus, plus. So you get a to be 1/2, set that factor equal to 0, and you get a equals -1. But then you have to remember we're solving for sine x. So at this point, I take sine x and I plug it back in for a. I need sine x to equal 1/2, and I need sine x to equal -1. And we answered those on the unit circle. We actually did sine x equals 1/2 a second ago. Happens at pi over 6 and 5 pi over 6. And then sine x equals -1 occurs down here at 3 pi over 2. So there are the answers to this problem. That's quite a hairy problem, but there you go. We will talk more about these in class. Pretty sure that's the last one. Yep, we'll talk more about these in class.